Um, in this problem, we're trying to solve the second order differential equation equals f of t, where the function f of t is 0 when t is between 0 and pi over 2, and cosine of t when t is greater than pi over 2. And the initial conditions are y of 0 equals 1, y prime of 0 equal minus 1. Again, because f of t is a step function, we are going to use the Laplace transform, and we'll get Laplace of y double prime plus Laplace of y equals Laplace of f of t. And Laplace of y double prime, we use the formula Laplace of y minus sy of 0 minus y prime of 0 plus Laplace of y equal Laplace of f of t. So now if we put this term with this term that has Laplace of y, we get s squared plus 1 Laplace of y minus sy of 0 minus y prime of 0 equal Laplace of f of t. And now we put that y of 0 is 1 and y prime of 0 is minus 1. So this will give me s squared plus 1 Laplace of y minus s plus 1 equal Laplace of f of t. Next, we move this term to the right-hand side, and this will give us s squared plus 1 Laplace of y equal s minus 1 plus Laplace of f of t. Finally, we divide by s squared. We get s minus 1 over s squared plus 1 plus 1 over s squared plus 1 Laplace of f of t. So before we proceed, we need to find Laplace of f of t. And for that, we know that f of t is 0 cosine of t for t between 0 and pi over 2, and for t greater than pi over 2. So using the UC's, this is equal to cosine of t u pi over 2 of t. So remember, for the sake of, okay, take c here. If you take 1 here, 0 here, that's the function uc of t, and some authors will call it hc of t. H stands for the initial of Heath side. So some authors will use HC and some authors will use UC. I'm going to use UC in this solution, okay? So the Laplace of f of t is going to be Laplace of um, cosine of t u pi over 2 of t. Now we use the table of the Laplace. This is e minus pi over 2s, Laplace of shifted cosine t minus pi plus pi over 2. And for that, we use um, trigonometry, okay? And that's minus sine t. So this will be e minus pi over 2s, Laplace of minus sine t, get the minus out, pi over 2s, and Laplace of sine t is 1 over s squared plus 1. So if I put everything together, I will find that Laplace of y is equal s minus 1 over s squared plus 1 plus 1 over s squared plus 1 times e minus pi over 2s over s squared plus 1. So this gives me Laplace of y equal s minus 1 over s squared plus 1 minus e minus pi over 2s over s squared plus 1 squared. So For the first term, for this one, okay, the inverse Laplace is easy. So now we have to use the inverse Laplace. So for this one, s minus 1 over s squared plus 1, that is s over s squared minus 1 over 1 over s squared plus 1. So this will give me that this is the Laplace of cosine t minus sine t. So this is the easy part. Okay? So the second part is e minus pi over 2s over s squared plus 1 squared. And for that, we're going to isolate e minus pi to s and try to find the inverse Laplace of this term. Okay? And for that, we're going to use the derivative formula because we have 1 over s squared plus 1 squared. So this is how we are going to go. Remember, the formula says that the derivative of the Laplace of f of t is the Laplace of minus t times f of t. I mean, you can have minus in or out on the other side as well. So if we take the Laplace, the one that will give us s squared plus 1. So Laplace, we can use either sine or cosine. So if we take cosine, for example, the Laplace of cosine, it's s over s squared plus 1. And if we take the derivative, we'll see that the Laplace of cosine t times minus t is the derivative of s over s squared plus 1. And that is equal to 1 minus s squared over s squared plus 1 squared. Okay? So, of course, here I didn't put the details of the derivative because this is calculus 1. Anybody can do that. Okay? So this is equal. So I need to decompose this a little bit so I can show the 1 over s squared plus 1 squared. That's why. So here, 1 minus, we have s squared. Let me try to get rid of it. So I'm going to have s squared plus 1 minus 1 over s squared plus 1 squared. 1 minus s squared plus 1. And then minus minus becomes plus 1 over s squared plus 1 squared. So we have 1 plus 1, that's 2 s squared plus 1 over s squared plus 1 squared. So now I divide, I will get 2 over s squared plus 1 squared, and then cancel the 1 s squared plus 1, and you will find s squared plus 1. Therefore, from this, so again, this is the Laplace of minus t cosine of t. So let's now, the one that we had is s squared plus 1 squared. So I'm going to take this term to the other side. Okay? So this is 1/2, because I don't have the 2, time 1 over s squared plus 1 plus the Laplace of minus t cosine t. So 1/2, 1 over s squared plus 1, that's Laplace of sine t minus t cosine t. And if I put everything together, I will have 1/2 sine t minus 1/2 t cosine t. So I'm able to find the inverse Laplace of this one. But the one we had was e minus pi over 2s over s squared plus 1 squared. Okay? So this will be e minus pi over 2s Laplace of 1/2 sine t minus 1/2 t cosine of t. So now let's use the formula. So we are going to put e, we're going to cancel the e, so this will be a u pi over 2 of t. And then we have to shift the function from t to t minus pi over 2. So this will be time 1/2 sine of t minus pi over 2 minus 1/2 t minus pi over 2 cosine of t minus pi over 2 here. So the solution is y of t equal the first part was cosine of t minus sine of t. That was this one. Let's go back to it. So it was this part coming from here, and then minus the one that we just found, minus u pi over 2 of t times 1/2 sine t minus pi over 2 minus 1/2 t minus pi over 2 cosine of t minus pi over 2. Okay? Of course, one can use trigonometry to replace the sine of t minus pi over 2 in terms of cosine of t, and the cosine of t minus pi over 2 in terms of sine of t. Okay?